So this one sounds like a very silly question, really. It's a bit of a silly question, I suppose, but it's not as silly as it sounds. Let's have a read of it. Bananas are a source of background radiation. Some people think that the unit of radiation dose should be changed from sieverts to banana equivalent dose. So yes, one reason why a banana equivalent dose may help the public be more aware of radiation risks. So there is a reason. In fact, this does happen. In other words, if you see the occasional poster and somebody wants to make you aware of how radioactive something is, they may actually say this this thing or whatever is about as dangerous as the radiation given off by a banana. So, or by 100 bananas or something like that. That's essentially what it's saying. So, what would be the advantage of doing that? So maybe the first question we need to ask is, why are bananas radioactive for a start? That might be the first question you might be asking. In actual fact, why is granite radioactive? Why are many things radioactive? Well, the same reason why anything is radioactive, because they're made out of atoms, and some atoms are radioactive. So, for example, bananas have, I think it's the thing that's radioactive in bananas is the potassium. That's what makes bananas a little bit more radioactive than something that doesn't have so much potassium in it. But let's just say, for example, in fact, I'm gonna get the potassium radioactive equation up. So this is potassium decaying into a beta particle and calcium. Now, it's just like all beta radiation, what's happened inside this potassium atom inside this potassium nucleus, is one of the neutrons has decayed into a proton, and that's how come the mass number stayed the same, but the atomic number has gone up by 1 because one of the neutrons turned into a proton. Now, not most potassium atoms don't do this. In fact, if you look on your periodic table, the potassium that you have written down the periodic table will actually have 39 written at the top, not 40. We'll still have 19 at the bottom because it is potassium. All potassium atoms have 19 protons, but this one has 40, mass number 40, so this one has 21 neutrons. So this particular potassium is unstable, and the one on your periodic table is not unstable. These are two versions, two types of potassium, or we can say two isotopes of potassium. This particular isotope of potassium is radioactive, and in other words, if you have lots and lots of potassium, then some of them are going to be this unstable atom. And of those, they're going to decay into this, and then this radiation here is going to be the radiation that is detected when you put a Geiger-Müller tube near a banana. So if I'm a manufacturer or some kind of company, and I have this material, or I want to reassure the public that there's nothing to worry about in terms of radiation, maybe at a hospital, right? So hospitals have X-rays and so on, and maybe the people going there might worry about the radiation being produced by this hospital. So if I said to them, well, don't worry, because the amount of radiation that is emitted from our hospital as you wait in the waiting room is so many millisieverts. Well, they don't know what a millisievert is, but they do know that bananas are quite safe. The idea of bananas being dangerous is a bit ridiculous. And so if I say again? That's right. So you want to compare it with something that we are familiar with. So if I say to you, the chance, if you sit in my waiting room for an hour, then it's about as dangerous as eating 5 bananas. Then you're going to say, oh, right, well, that's not very dangerous then. So if I say that instead of it's this many millisieverts, then you're going to be more likely to think that it's not that dangerous. So basically, people know that bananas are reasonably safe, and so if you're trying to communicate to the public, oh, this other thing that you're wondering about whether or not it's dangerous, like a mobile phone maybe, or a doctor's waiting room, or an X-ray, or something like that, then you might want to explain to them that you can use something they're familiar with to demonstrate that the thing that they're worried about is perfectly safe.